Okay, hello. This is just a short tutorial to our boilerplate blockchain and our cryptocurrency we are running today. So here I have the script. I just go quickly through it. We have a class which is called blockchain, and this class has different methods and different variables. First we have a create block, then we have a get the previous block. It's more or less self-explaining. We have the proof of work algorithm, which is the workhorse of the whole stuff. We have the hashing, we have the check if the chain is valid, then we have the add transaction method, we have the add node method, and we have the replace chain or the consensus method. These are all the methods, and now down here second part of the script is just for running. It's just basically just an API call for almost each one of these methods. So you can see here we start we initialize the class, we assign an instance of the blockchain class to macaco, which is our currency, the maca coin, or monkey in Brazilian Portuguese. And then we have the first API call. So this API call is called mine block, and it's a get request, and it's just calling some stuff in. This is basically mining a block, okay? Then we have the get chain. This is just checking or returning the whole chain. And then we have the check if it's valid. We have the add transaction call. Then here we are going to decentralize the whole blockchain. We are going to decentralize it by connecting it 3 nodes together, and then the replace chain, which is the consensus protocol, which checks which chain is the valid one. So how are we going to simulate this? This is all running on my machine. So what I'm doing, I have 3 times the same script. Once it's called Michael, once it's called Garrett, and once it's called Paul, simulating a node or a wallet of each one of us. And really the only thing which is different in each one of these 3 scripts is just the address, the port. You see here, Paul has 5003, Garrett has 5002, and I have the 1. So this is just the place where it's running. And now what I'm doing in Python, I'm just opening 2 more consoles. This is kind of simulating 3 different machines, even though it's on the same machine. So, and now I'm starting the app. I'm just pressing go, and now we see my script, Michael, is now running on this IP address with the port 5001. Now we're going to the second one. We're starting Paul. Paul is running on same IP address 5003, and Garrett, we will do the same. Just started and it's running. So now it's up and running. The app is running on my machine. Now we can interact with the chain, and we will do this through Postman, which is just an API gateway. We can also do it through the browser for the GET requests at least. So I just made a little tutorial here where we have all the commands which are relevant. So what we first want to do, we first want to get, this is actually not Garrett, this is mine. We want to just get, oh sorry, that's not what we want to have. So I have to copy it and put it here. So you see in this window, in this tab, I have 3 tabs also for the 3 nodes. And this is just simulating the app. Of course, in real life, whatever I'm doing here in this screen will be done by an app, which is much more user-friendly, and all the stuff is automated. But here I'm just simulating the API calls. So here I'm just getting the chain from Michael's node. Then I get the chain from Garrett's. Oh. So I just have to replace correctly the 2. You see what we're doing, we are just starting the blockchain or the macaco, and it's just making the genesis block. And same here. So at this moment all the three chains are completely independent. They do not know each other, okay? We're going to change that now, and for this we have a second call, which is the connect node call, and we have to do this for all three nodes. So, and we have to take care, this is now a post call, no longer a get call, and this actually is a bit complicated. This needs a body, I have prepared that as well. It's actually quite simple. What it just needs, it needs just a key nodes, and then now here I'm on Michael's node and I want to connect to Garrett and Paul. So from the 5001 I connect to 502 and 503. Let's do this. Slightly nervous. Okay, it's worked out. And I have to do the same for the other ones, right? So again, all of this is done automatically. In the instance you start a wallet done by the app. It's just connecting, and it's just a bit tedious here because we are doing this all just for testing purposes. Just doing the work here. So here we are on the node 2. We have to connect to the 1 and 3. Done. And here we have the node 3. We have to connect to 2 and 1. Done. So now the three nodes in the background, they know each other, okay? So what is next? Let me just spy here. Yes, we can mine a block. Any one of these guys, now we have to go get back to the get request. And I will just do something else just to show how cool it is. But I can do a mine block, but I will not run it here on Postman. I will run it on a browser, so you can see it's not something made up, it's just an empty browser. I can even do a new tab here, throw that in. You see it's exactly Michael's node and mine a block. So it tells me, congrats Michael, you just mined the block, you get one monkey. You guys know that macaco means monkey. And it gives me actually here one macaco to my wallet, okay? So I can now check, the get chain is always our check. We can actually hide that because now we are still in a get request. You see, I have indeed in my chain, I have now 2 blocks. I have the Genesis block, and now I have the new index 2, the new block, which is the reward which Michael got, I got actually, for winning the mining contest, okay? The problem though is, if we go now to Garrett's wallet, and we do the same, we see that he still has the old chain. He does not know that Michael just won the contest, and hence he disagrees with Michael's money he got, okay? And this is actually the basic problem. So the fact here, this is very important, as we don't have a centralized system, each one runs this stuff here, what you see, on his own computer, on his own machine, right? So there is no central instance which makes sure that everybody sees the same stuff, and hence we have to make the consensus, run the consensus to balance this, or to make sure that everybody talks about the same or has the same information. That's what we're doing next. So we have a third call, which now we mine the block. And now we are on the consensus protocol. We have to run this for each one. In reality, in real life, this of course is also done directly by the app. This is kind of automatic. So this is called replace chain. And then I will do actually this first in Paul's algorithm. sorry, in Paul's node, replace chain. You see, it's still a get. I do this, and now, oh, cool. He gets a message, the nodes have different chains, chain was replaced by the longest one. And we have to do this also, it doesn't do it for anybody. You see Garrett has still the old one, so he also have to run the replace one. And why don't we throw this in the browser just for fun? So he gets the same result. His chain was also replaced by Michael's, because Michael indeed had the longest chain, because he was the last to add a node. So I can run the same on my wallet, and I got the same blocks, but I got a different message. Okay, the chain is the longest one. I was already in possession of the truth before. Okay, so so good, so well. Now we wanna actually, let's say Paul is very generous and Paul wants to send me some monkeys. Okay, so we have another call, which is called add transaction. So here we add a transaction. We take Paul's node, right? And this is also a post, because we actually post one, we don't get, post something, we don't get something. So I need a different structure. I need to put the information about the transaction here, and this is in fact the protocol. This is what I defined. What the fuck? Oh, Control C. That's what I want. So this is what I defined when I coded up. I made the code. I just said, okay, a transaction is just made of a sender, Paul, a receiver, say Michael, and an amount, say 20 monkeys. Okay, that should be good. So just a little information. This kind, if we talk about post requests, you cannot run them in a browser, because there is nowhere where you can place the message, the information itself. Just the get ones you can put in the browser. Okay, so what we see, message, the transaction will be added to block 3. So we know that there are already 2 blocks. Let's get the chain. There are already 2 blocks in, and you see at this moment the chain still doesn't know about the new transaction. Also this one doesn't know it. Still 2 blocks, and also we can go back here, hide this, and also Paul's own chain doesn't know about this. Still you have only 2. Why? The transaction is not yet mined. It's just in the mining pool. That's like a memory where all the transactions are in. So it needs to be mined. So let's say Paul now mines mine block. Is it like that? I hope I didn't misspell it. Yes. Okay, so congrats. Now what we see is that we get indeed 2 transactions which have been added in this new 3rd block. So first of all, Paul's generous donation to Michael is inside the block, because this has been waiting in the pool. And now also, as Paul won the mining contest, he also got for himself a reward. This is actually newly issued currencies, or newly issued MACADAOs. That's the way that's kind of the central bank of a cryptocurrency, right? That's how the Fed issues new money in this sense. So now Paul knows, Paul has now this chain complete. You see, we have 3, but still if we go to Garrett, the same as we had before, he only has 2. So he has to run the consensus. And of course Paul's chain wins because he has the longest one, and the same is valid for Michael. So let's do that. Okay, so now we are here. Everybody has the truth, and now we can actually go ahead and send currencies back and forth. Um, but this is basically what I've been doing so far. I want to highlight 2 or 3 more important things here. 3 known issues actually. Um, so in fact, it can happen that 2 nodes mine at the same time, and then they both have the longest chain. For example, let's say now Garrett makes a mining and Paul makes another mining at the same time. Then everybody runs the replace chain, and then it conflicts. And this is in fact happening. This happens in Bitcoin especially because it is possible that 2 nodes win the proof of work at the same time. It's much less likely though, because in reality it's not just a blink of an eye which it takes. It takes a lot of power, a lot of computation power, and it's very unlikely that 2 nodes win the contest at the same moment before it gets broadcasted to the other nodes. But it happens, okay, and when it happens, it forks, the chain forks. Whoever is closest to Paul will go with Paul, and whoever is closest to Garrett will go with Garrett. And then Garrett's people will win or not win other mining competition, and Paul's people will win their mining competition. And at each instance, they compare again the chains, and if Paul is slower, then it's his bad luck, so he's out of luck. Then his chain will be replaced by Garrett's chain, and all his transactions will be invalidated. And that's what's called finality. So after 5 or 6, it is unlikely that 2 win at the same time. It is even less likely that then in the next instance again 2 win at the same time, and it's less likely even that then 3 win at the same time, and so on. And it's considered after 6 rounds. After 6 blocks, that's about an hour in Bitcoin. It's impossible that we have 2 chains which have the same length. One will prevail, and the other one is then just deleted. That means just all transactions which have been inside these blocks, they go back to the mining pool. They will be mined in the next round by the prevailing chain. Okay, so this happens, and this is a weakness of Bitcoin actually. Then the second one. You can here spend money for another person. For example, I can go here and I can make a post request. I can, oh no, I do it here because here the information is already in. Add transaction raw, you see. And now Paul, let's say Paul is a smart cookie, and you say, well, I will send Michael another 20, or let's say generous $50, but I will charge it on Garrett's wallet, right? So you can do that and it will go through. There's nothing which hinders you. You can now mine that, and if you win the mining block, oh shit, of course that's a GET request, that's why it's going wrong. So, and now if the other guys do replace the chain, you see, Garrett will be surprised tomorrow morning when he learns that Paul just spent $50 in his name, and there's nothing he can do about it. It's kind of a FTX-like chain, right? You can spend money which you don't have. Little jokes aside, but that's incomplete. I didn't do this yet. Usually, this is prevented by the fact that before or when you add a transaction, it's basically in this moment here when you see the text here, there is also signature going in, and you sign it with your private key. It hashes the whole message with your private key, this goes then into the mining pool, and whenever the whole consensus protocol runs, it will automatically check if this signature has been made with the private key, which belongs to the public key, i.e. the address of Paul's node. So this doesn't go through. What Paul just did here wouldn't go through in a real blockchain, okay? But it was a nice try. And then there's a third point. Let me just read. I kind of forgot it. Fact signature. Oh yes, that's just yes. So this is one thing that you can spend money on behalf of other people, and the third one is you can spend money which you don't have. Maybe you noticed that Paul spent $20 in the beginning, which he doesn't have. Get Jane. So you see, he never had this money. He just spent it. That's actually the FTX joke, right? But this is also wrong. Respectively, I didn't do this. Usually, how this works is blockchains do not know something like a sum. What they just do is they just close transactions which have been spent, or leave open the ones which are not yet spent. So what you would have like a flag behind each transaction, say, okay, you are spent or you are not yet spent. So then Paul, when he sends $20 to Michael, he needs to select a transaction, an incoming transaction, which is bigger or equal to 20, right? So that means that he cannot do that. That's kind of just a sum and if else part which is missing still in the code. So these are the three flaws I have here, and the rest, yeah, in theory we could just set this up on a server or on 3 servers or 3 machines, and then it would be working the same way. Okay, so that's it.